If you think you've seen DHI perioperative risk stratification tools published and presented before, you thought right. But don't go. This work had a strong baseline with Dr. Kristen Corey's Pythia models and Harvey Shu's Python web app. They used EHR data to curate procedure, comorbidity, and therapeutic groupings and used ICD-9 codes occurring 30 days post-op to predict surgical complications. Harvey Shu built an app that could collect all surgical procedures scheduled over the next 30 days and, within 20 seconds, provide those patients risk for multiple surgical complications. The results from these models were published and are fantastic. The AUCs range from 0.772 to 0.924. Other statistics aside, why not refer to the last conference's presentation and stop there? Leading surgeons came back to us seeking to create a geriatric-specific version of the Python model. Geriatric-specific risk stratification is important because today, older adults comprise 37% of surgical cases at Duke, and the percent of the population older than 65 is growing and increasingly undergoing surgery. Our goal is to be proactive about surgical case planning and early intervention. Previous Pythia data wasn't available until a surgeon had scheduled a case and was committed to planned procedures. This means the train had left the station. The opportunity to change course or prepare the patient for surgery has diminished. Furthermore, we learned that factors used in Python version 1 were insufficient for capturing issues geriatric patients face pre-op. We needed to design an application that could be used before a case is scheduled and a model that uses ground truth and geriatric-specific data inputs and outputs. Ground truth data are what healthcare providers collect and document that, with thresholds, determine the diagnosis itself. If we collect this cleanly and reliably, we capture clinical decisions that may be missed by codes used by revenue managers. The geriatric-specific model demonstrates a performance of 0.92 and 0.29, the AUC PRC respectively, compared to the all-surgery model, which scored 0.95, 0.35. Improving inputs using labs, vitals, activity status, and cognitive measures, for example, increased the published Python 30-day model ROC from 0.916 to 0.951. We plan to reassess which complication predictions are most actionable and how to best define those with ground truth data. This app is easy to log into while on Duke's wireless network or VPN. Surgeons can access it through phone app, web link, or link in Epic. The surgeon enters the patient MRN and one or more CPT codes. These parameters go through a path including a PostgreSQL function, API, model, JSON response, and Tableau query, all producing results in fewer than 3 seconds. Thank you.